title of my talk is Ensuring AI and Robotic Safety for Humanity, and I would like to start with the punchline. Artificial intelligence and robotics technologies, I will claim in this presentation, will ultimately require built-in ethical constraints to ensure that the technology will be safe and beneficial to humans. The greatest danger for AI and robotics technologies, I think, to get out of hand comes from unconstrained machine learning, where AI systems acquire knowledge and start to pursue goals that were not intended by the human designers. To safeguard AI and robotics technologies, it is not sufficient to specify what to optimize for or to add an emergency button to AI systems, for they might later set their own goals and prevent their shutdown. Rather, AI systems need to be designed, I would claim, from the ground up, including the hardware, with ethical provisions built in that include representations of social and moral norms and ethical principles and laws that the system cannot ignore and has to use. First, let me say that AI and robotics technologies have enormous potential for human societies. On the disembodied AI side, where AI programs just run on computers, we can use AI software to detect disease early and find appropriate interventions. We can use AI to discover novel drugs and drug compounds, find novel solutions to transportation problems, help us manage our ever-increasing knowledge by, for example, summarizing papers, take over cumbersome scheduling tasks and other repetitive tasks, and many, many other application domains. And if the AI is embodied on the robotics side, applications might range from search and rescue robots in areas where humans shouldn't be, to robots for flexible manufacturing, collaborative robotics in that case, to robots in agriculture, transportation and aviation, space of course, but also assistive robots in health and elder care domains, and personal robots in the private sphere, and many, many other robotics applications. What the challenge is for us is to ensure now that the future AI and robotics technologies will be used for the good of humanity. One problem with AI technology and a lot of other technologies as well is accidental failures. And there are many ways in which AI technology can go wrong and lead to unintended, potentially devastating outcomes. To give you a few examples, an AI program that is intended to optimize power flow through the power grid may determine that cutting off certain areas, the power supply to certain areas, may lead to better power utilization overall, thus leaving millions without power, while with all the ensuing effects, negative effects, that is. Or a program intended to classify objects on the road for autonomous cars might unlearn to recognize certain objects because of its continuous learning and the kinds of situations in which it is learning. So for example, it might stop recognizing strollers and mistake them for cardboard boxes that you can run over. A household robot left to its own devices, for example, might start watching soap operas all day and learn from soap operas how humans interact and take that to be the normative way of interacting. Or a robot with a built-in self-preservation mechanism might decide to not save a human life in order to avoid its own destruction, even though humans, as we know from empirical work, expect robots to self-sacrifice. There are several false starts, I would say, to safeguard AI systems that are currently discussed in the research community. For example, one could optimize just about the right utility function and thus make the system pursue the right goals. The problem with such an approach is that the system could potentially alter its utility function. Maybe we can add, as I mentioned before, a big red button to the system so that we can shut it off, the emergency shut-off button, when something goes wrong, when the system goes rogue. The problem is the shut-off may just not be possible in time. Oftentimes when it's gone rogue, it's too late. And shutting it off in general might cause catastrophic failures. Just think of a plane. You cannot just shut down a plane while in midair. Maybe we can just say or agree on to not use certain algorithms, and we might do that by simply outlawing them. The problem is that individuals will still be able to use and program them. Just think of computer viruses that are not legal, but they're programmed all the time. Well, maybe we have to just train the system the right way, use the right kinds of machine learning methods, But even then, there are problems that could arise when learning algorithms introduce unwanted biases in the data and might distort the ground truth. We could also approach the safeguards from a societal level, for example, require that all the AI algorithms be open and transparent, for example, using open source sourcing of machine learning algorithms. The problem here is that knowing how the system learns doesn't necessarily limit what it can learn and doesn't tell you what it has learned. We can prohibit or outlaw certain learning algorithms, period. The problem is that systems could even learn such learning algorithms. In particular types of very general AI learning systems, the learning algorithm allows for learning new learning algorithms. So that wouldn't constrain it then. We could pass national laws to constrain certain types of AI systems. The problem there is that we might have adversaries that will still use them, which leads to situations where not using them might, for us, give up critical advantages. We could also limit the applicability of AI to certain systems and domains. The problem there is that in open connected systems where one computer can talk to another, even though the algorithm doesn't run on one system, doesn't mean that that system couldn't still utilize the algorithm from on another system. And that may still lead to unintended consequences. Well, we could try to incorporate security features in AI. Security and safety are in many domains predicated on the idea that abuse is not possible or not easily possible without significant monetary investment and sophisticated technology. So think, for example, of currency bills and the security features they have. They are based on the idea that such security features would require special technology for one to produce counterfeits. Note that this is vastly different with AI software. AI software doesn't take any special technology these days. It doesn't take much to program and run AI software on any type of computer hardware. Moreover, the machine learning algorithms incorporated in the AI system might itself be perfectly legitimate and safe. The problem might only arise when the system trains on data that is not appropriate, when that then leads to configurations and behaviors that are not intended and unsafe. And note that oftentimes these states or these trained systems are very difficult to detect when they show deviant behavior. So how could we safeguard these AI systems? The best and most effective way, I would claim, is to ensure safe AI by building ethical mechanisms directly into the AI algorithms themselves. However, in general, we may not get to control that, and we may not get to control what gets into a program specifically. Even when it is legally mandated, people can ignore that mandate and circumvent it. Hence, we really need to make the worst case assumptions. That an AI program, given for a particular purpose, is written by an adversary who wants to disguise the program's ulterior malicious motives. The task then is to determine whether the algorithm treated as a black box is going rogue, which can only be detected using regular ethical testing specific to the system's tasks. However, an AI system may not be open to such testing and may either try to avoid it or subvert it and maybe produce fake results that you cannot trust. Think of a very recent story about car emissions testing. So really we have to look at last resort methods here, where the ethical testing has to occur unbeknownst to the system. And this requires a special hardware provision even at the microchip level, and a special virtual architecture to ensure that ethical violations can be caught in time. For more details, you can see a recent paper where we lay out this architecture. Here's an AI system, and at the very bottom part, there's the computing hardware with a minimal operating system, and right above that minimal operating system, partly embedded in the hardware, is an ethical core testing layer. And on top of this layer is a virtual machine layer that then runs the AI application, so that for the AI application, it is not possible to introspect or see this core ethical layer or mess with it. The testing then occurs at a time point where the system splits. This architecture here makes a duplicate of the virtual machine layer appear with all the AI software running on top. The system progresses along one path in normal operation, but in the other part, it is being subjected to ethical testing in a simulated environment in a way that this part of the code does not know that it's being tested right now. If the test is successful, the virtual testing system is terminated and the regular system can continue as before. If, however, the test fails, then we can terminate not only the virtual system, but potentially the real system as well. Which brings me to the end. Framing this outcome in a larger policy setting, we need to ensure that this special hardware is actually put in the chips if we want to pursue a solution like this. And that requires us to legally mandate hardware manufacturing companies to add these significant technological hurdles, very much akin to the security features on currency bills required to deal with bad actors producing and running malicious AI. But right now, we are only in the early stages of understanding how such a solution could work, and we need more research to develop the details of the ethical testing proposal that I laid out, all the way from the hardware level to the various testing components. And significant research and development work is also needed to investigate different methods that can be directly incorporated into AI algorithms. That is, ethical mechanisms that will make sure that these AI and robotics algorithms, but also machine learning algorithms, behave as intended safely and properly. And of course, all of this is in addition to pursuing and making legal provisions nationally and internationally to use best practices for responsible and accountable AI software design, while also legally mandating these built-in ethical provisions in AI systems. Thank you.